Okay. So, since work has started on the official Zig package manager, I thought it would be kind of fun to talk about package management. I was listening to an episode of Software Unscripted recently, which is a podcast. There's an episode of it where Andrew Kelly was on. It's a really good listen. Oh, yeah, Richard Feldman. Yeah. There was a more recent episode where, as kind of like a small tangent, they had some interesting discussion about package management that made me very manic and decided to do a talk. So, there we go. So there's a lot of prior art for programming languages with package managers, right? There's NPM for JavaScript, Conan and VC package, and a bunch of others for C and C++, Pip for Python, Hex for Erlang, Elixir, Lean, Cargo for Rust, Opum for OCaml, Package for Haskell, Elm for Elm, and then countless system ones, PKG, APT, RPM, Brew, whatever. All the Windows ones. I'm going to talk about NPM the most because it's what I know, because I do TypeScript professionally. But with all of these in mind, what could we do better in Zig? We're starting with a blank slate. It would be kind of a shame to make a lot of those same mistakes, right? So, what are some of the known problems that we need to solve? There's the left incident. For anyone who doesn't know, I think it was like back in 2016, there was a package on NPM called LeftPad that got forcibly unpublished by the author because he was mad at NPM. And it just happened to be a deep nested dependency of Babel, which is a JavaScript to JavaScript compiler that was really, really popular at the time because it was when JavaScript was evolving really quickly, but browsers still mostly only implemented like ES5 or 6. That was really all you could count on. So it gave you a way to use the newer features and not leave older browsers behind. And because LeftPad got removed from the registry, people's NPM installs just like started immediately failing in their like CI/CD systems. So the moral of this story is pretty easy. Don't let people delete things, ever, at all. Why was that an option? Everyone pretty immediately agreed after it happened that that was a terrible idea, and that you just shouldn't let people delete packages that are especially widely depended on. But NPM has had a number of other incidents as well, like the Faker package, which the author updated to just be an intentional DDoS, or Node IPC, where the author decided to just commit literal cyber warfare against people that he thought may or may not live in Russia. There's also managing upgrades. Most package managers for programming languages have log files to make sure that all of your dependencies are getting the right versions of their dependencies. And I don't know if you've ever looked at a package log.json or a cargo.log or whatever, but they can be hundreds of thousands of lines. These are very much not trivial. There are also concerns of supply chain security. If vulnerabilities get introduced downstream, or maybe your dependency adds some other shady dependency and then you just never even find out about it. And then the obvious thing, like what if I have some dependencies that need an incompatible version of some other dependency, or if I need a version of it and then I have a dependency that needs a different one. There are problems with just naively including multiple versions of the dependency, like bundle size, compile times, and just like general complexity of your program. This is a fun slide. You might, for various reasons, not like the dependencies of your dependencies. If there are licensing conflicts, I'm sure everyone in here has heard of the GPL virus at some point, and that's like a whole separate thing to talk about. But for some people, that's a concern that they have. You might also just be missing features in one of those downstream dependencies that theoretically, if you had the ability to just swap it out yourself, you'd be able to get additional functionality from the thing that you're actually using. But you can't because the maintainer of that package made like some choice that's not really working out for you. They could also be using a dependency that's just slow. Maybe it came out before there was some like new algorithm or new data structure discovery or whatever. Or it might just like not be very well implemented and you're stuck paying for that poor performance. Other general disagreements, like if you have a dependency that uses some sort of logging library that like is different from what you want, and you'd really just rather use your thing. There are also wasted cycles. NPM in specific, I just find wildly inefficient. So it'll do a GET request to go download the library, it'll uncompress it, it'll extract all of those files to the disk. Those first couple steps you can't really skip, but if you've ever trolled through a node modules folder, you'll notice that there's just like a ton of stuff in there that super doesn't matter. It'll unpack all of the licenses for everything to disk, which you could talk about, well, a lot of the licenses say it has to be distributed with the source code. Okay, fine. Why does it need to be written out to the disk though? Because it's still in the tar archive. You're still doing that. You could just save yourself the step of writing out all of these tiny files. Package.json, that's a bit more necessary than the rest of these, but there are still ways that you could get around that if you really wanted. And then there are also just a ton of files that super don't matter, like codes of conduct, change logs, readmes. You'll find lots of .github folders that contain issue templates, pull request templates, CI workflows, all of that. Files like editor config, ESLint, whatever. None of those serve any purpose when you are a consumer of this library, but their presence is part of why NPM installs are so bad, because you're wasting seconds upon seconds upon seconds that add up to minutes just writing out these thousands and thousands of tiny files that do not matter. And then do that thousands of times for all of your dependencies, and it really does add up. There are also not just wasted CPU cycles, but dangerous CPU cycles where packages can just kind of run whatever code they want the second that you install them. With NPM has post-install and prepare that you can disable, but it'll break everything, so no one does, and it's enabled by default, so no one's even going to really think about it unless like you really have a high security need. Or you've got like a big enough company where it's somebody's job to think about these sorts of things and they have mandates about it. But this isn't just an NPM specific thing. Python has setup.py, Rust has build.rs, and potentially we could have built .zig, and that could be a dangerous thing. Because right now we have all of that for our executables, but I think we should think about if that's actually something that we want libraries and packages downloaded from the package manager to be able to take advantage of. Because in any other context, remote arbitrary code execution would be considered an absolutely disastrous outcome, and yet for some reason this is a state that we accept from the tools that we use as developers. We can do better than this. So let's talk about potential solutions. An easy one would be to just not have the package manager. And like, this might sound a little bit silly, but think about how far Zig has gotten without one. Like your talk earlier was really pushing the point of don't just go along with assumptions. Don't assume that something is the best just because it exists and it's there. Maybe there are ways to look at the problem differently that lead to a much better outcome. And this could potentially be one of those things. But package managers do have good bits, and they're the evil that we know, at least. They give a lot of things like code reuse, which lets you learn from the lessons of other authors while they were writing that code. They certainly learned lots of things from that process. You can save yourself the time of having to go through all of those lessons. They also enable you to just build the thing that you're actually trying to build and solve the problem that you came here to solve without wasting time on building things underneath that you could just assume are solved problems. problems, because even if there would be ways to improve it, that's not the work that you're trying to do. And ultimately, like, we care about finishing things and not just spending forever spinning wheels rebuilding things. And they enable working together, because open source is cool, and having package managers that enable us to really easily work together encourages more people to do it. For avoiding vigorous cycles, how about we just don't let people run whatever code they want on our computers? NPM kind of lets you solve this by, like, if you've ever looked at how ESBuild installs itself, the actual ESBuild package has a bunch of platform-specific dependencies, and then NPM will figure out which one of those platforms matches where you currently are, and it will only install that one. It's super janky, and it feels really hacky, and it's really hard for package maintainers to set up, but it's at least something. And if you don't want to put in all of the behavior or all of the work to allow these packages to describe the behaviors they need in a different way that's not just arbitrary code execution, you could at least ask users if they're okay with these install scripts being run before they happen. And you can maybe even enforce that they happen in a way that's cacheable, so that it only needs to run one time per package, per version. They get asked every time that it happens that first time, and then it never runs again. It's just always a cached result, so you don't have to worry about it. Avoiding wasted cycles, NPM very quickly learned that they just should cache package downloads locally on your computer in an immutable cache. This feels like an obvious enough one that it's kind of surprising it took them as many years as it did, but at least they got there. You can also come up with more bespoke package formats that don't need you to just dump files onto the disk, so they can be stored in that immutable local cache, and then they can just stay there. And then your installs, all they need to do is download things that aren't already there, and otherwise they're free. When I worked at Dino, we had something called ESZip, that's probably still in use, but it's basically just a fancy tarball that enforces that JavaScript files come first in the order that the runtime is going to expect them, because it's generated directly from those source files. We know the order that they're going to be imported in, and we have all of the source maps for them and everything, so they can be lumped in at the end of the bundle. And then you can just have this one single file on your file system that contains the entire module graph, and then you don't have to entirely unpack it. You just need a runtime that understands how this format works. Rust has .crate files that it downloads from the registry. They are also just fancy tar files. You don't even need to have a facade around it, like just download tar files and then load the source code from the tar files. When you have an uncompressed tar file, it's just like linear files in memory that you can load from the disk at a single point. It would be really easy to just have the build system be smart enough to load packages from those. A more interesting point, what if we just didn't let the libraries that we depend on other libraries? What if we enforced that dependencies had to be just a single flat list instead of this deeply nested tree that we typically assume it's going to be? And this might sound like kind of a crazy idea, and you might be wondering how it would work, but this is one of the first concepts that you're introduced to as a Zig programmer. Standard array list has a dependency. It has a dependency on a memory allocator, but it gives you the responsibility of telling it what allocator it should use. This is typically called dependency injection. It's really common in lots of other use cases. If you look up how to make an HTTP request in Zig today, you'll probably find a library called requests. The documentation will show you an initial script that looks like this, where you just initialize the client by passing it an allocator. So what if you just also had to pass it a way to connect to TCP? Or what if you had the ability to you can imagine this is some struct that has a bunch of functions that would enable whatever is necessary to like have HTTP3 support for free, just by swapping out the backend that the client is using. There are a lot of benefits to this. You don't need log files because the package manager just downloads exactly the list of dependencies that you told it to. You don't end up with version conflicts. You don't end up with package managers trying to resolve version conflicts in weird ways, where you end up with like a dozen copies of one library without you knowing it. If you have a dozen copies of that one library, it's because you told the package manager explicitly that that's what you want. And because of those simplifications, the package manager itself and the code base behind it gets much, much simpler, because it doesn't need all of this weird resolution logic. You also don't need weird things that NPM has, like peer dependencies, which pop up in React a lot. If you know this problem, it's super obnoxious. Basically, the problem is that like you might have two things that need to get the exact same version of something, and they're a really terrible interface for describing that relationship. If I need two things to have the same version of something, why am I not just passing it directly to that dependency? Why am I not just importing it myself and saying, this is the exact thing that I know I need in all of these different places, and I can give it to everyone by hand? It's much more durable that way, and if we're trying to build actual reliable software, that's what we should be doing. All of your dependencies become explicit. You're not going to have any weird code downloaded that you don't know about, because you have a single level and you have to say all of it yourself. You also get to own the glue code between all of these. So if one of the dependencies of your packages gets a new major version and there's some small breaking change, you don't have to wait for one to be updated to support the other. You can just go in and fix that glue code yourself. And then since you already owned that glue code and you already went through the effort of figuring out how they work together now, you could maybe go to one of the projects upstream and provide that as a patch that everyone would be able to benefit from, because it motivated you to do the work locally in the system that you care about. Maybe not everyone gets to benefit from that. And also, since Zig has comp time, like, you can basically do this for free. All of this passing around is going to be done at compile time. So, yeah, like that's a bit extreme. It's maybe not actually the right idea to just entirely disallow this, but I think that these sorts of things are worth thinking about. I think that it's worth thinking about if the way that package managers work is actually like in our best interest. Less dramatic ideas be around. We could have some sort of moderation. Most language package managers don't have this because you have to decide who's going to do it, and it's kind of a thankless job. That's a lot of work. You also have to like pick people who you trust to do it. There are different levels of moderation you could do. Like one of them is maybe not actually moderation, but just make sure that people who can upload packages are real people, do some minimum amount of verification before they can just start uploading like whatever weird ROMs to NPM. Like there's lots of crazy stuff that happens there. Or if libraries were able to have dependencies of their own, what if adding a new one was a breaking change so that people downstream would actually like be forced to know about it? You could maybe even do the same thing for adding new maintainers. That's maybe a bit harder to enforce because a lot of people will just set their packages up to publish automatically from GitHub, and then how do you detect if you like gave write access to someone on GitHub, and like how would that be a breaking change? There's complication there, but you could also have upgrading be more interactive. Some hypothetical Zig upgrade command could give you a decision tree saying, this package has a new major version because there was this breaking change. You can say, oh, we don't use that. That doesn't matter. We can use this new version that like also has some security fix or whatever. You could have it tell you people have been added as a maintainer so that you know there's like a new person in this chain that you need to trust. Like, these aren't all perfect ideas, but I think that going along these threads is something important to do. I think it's also important to remember that package ecosystems are largely culture ecosystems. They form themselves from the people in them and the way that those people think that code should be written and the way that it should be formed. So if we want a package ecosystem where we get to trust and enjoy the packages that we use, where we can enjoy creating libraries for people, and where we don't have hundreds of libraries that all just implement some single function that should have just been a part of the standard library, if we're not actively seeking out those things, then we only have ourselves to blame when it doesn't happen. As the closing thought, if you're writing a package, it's important to keep the language that you're writing for in mind as you do it, because languages have idioms and ways of doing things that deserve to be respected to have your package feel like it's a cohesive part of things. And I think a language like Zig that focuses so heavily on low-level control deserves a package ecosystem that gives you the same kind of respect. And I think Zig is a really unique language that deserves a really unique package ecosystem. That's all. Q's, A's?
Oh.
I can B slightly B.
The one thing because I spend time in both TypeScript and Go a lot, and NPM is everything wrong, right?
It's so bad.
It's all the things wrong. But the interesting thing about the Go way of doing it is that because when you import, everything is explicit, and you do if you go back to your slide about having no package manager. The irony is the Go way of doing it, basically there's a proxy that you can do whenever you grab your stuff, you grab it through the proxy, but you can also just pull directly, and if enough people pull from it, it automatically goes into the proxy. There's an in-between step that it's not just no package manager yet. It's very much what it seems like what would work in Zig. I'm curious how much, I've been involved in the package manager stuff, so I'm curious how, because NPM's wrong, but Go seems like it would fit better.
Go is a very interesting, it has a very interesting model for dependencies, where there's no central package manager.
But there's a central proxy.
You just have Git repositories that have to behave in a slightly specific way, but basically anyone can host anything, and then you just have URLs to those repositories as your dependencies.
Yeah. But you get a proxy that has all the documentation automatically generated and all that stuff for free, but you also have to opt into it. So I don't know if there's something like that. Well, now you do. Yes.
They source that.
Yeah.
Yeah, it's interesting. And actually, Elm also kind of does something similar, where basically package names are just GitHub user / GitHub repo.
Crystal does as well. Crystal's package manager shards it's all just Git repositories.
But the Go one doesn't have to be GitHub. It can be literally anywhere, and it doesn't have to be
just Crystal technically.
Okay.
Yeah, but it does if it's not
explicit.
Yeah, the way it's explicitly defined in the code is GitHub or GitLab, where you can just say Git and then put a Git repository.
Yeah. There's subtlety there though. It works for Go because they specifically have the Go proxy.
Yes.
So if I decide to just fuck off tomorrow and delete all of my GitHub repositories, people who are using them are still going to have it cached by the module proxy. Whereas in Elm, this is very much flipped on its head. If someone deletes or renames a GitHub repo, everyone's day is ruined. I actually have a friend who's really prominent in the Elm community who changed her GitHub handle. And it just it ruined everyone's day in the entire Elm community. It was really bad. So that's definitely not what we want, but...
Yeah, I guess it's just the only thing I'm would that Go thing make sense? Or is it not the right look? Because it's curious if...
I definitely think it could work. And like another concern that you might run into is Go is run by Google, who's just like this massive company that can afford the resources that it requires to run the Go module proxy.
Right.
Can Zig afford that?
Can they afford not to? I don't know.
Yeah. And I mean, like, if it's more of like a centralized repository like NPM, then you're still footing all of the traffic costs. So it's something worth thinking about for sure.
I really like the idea of no dependencies for dependencies. I think that does a lot to make it makes the cost a lot higher for people who are going to be adding dependencies. Like then they have to go add all the dependencies for dependency. And makes it explicit.
And I think having that back pressure is maybe a good thing, so that you don't end up with like the JavaScript projects that have 10,000 dependencies and they thought they had like 7.
Yeah. It's definitely an issue. I would say, I think what you said about culture is very true. I doubt anyone here would looking for the left add function.
Yeah.
I mean, the JavaScript implementation of it is usually like 3 lines if you weren't used to building.
Yeah.
Well, how would you handle something? Sorry, it was just like the game like the mock engine. Like it has to rely on GL and all this. Like it has to rely on OS specific stuff.
Yeah.
So how do you handle that situation?
And packages that are that big and where the dependencies are that specific,
Right.
those are exactly the sort of thing that I had in mind when I had the slide that's like,
but
this is a crazy ideal to strive for, but it's maybe not actually practical. Circling back to, what was it that you said? I'm totally spacing.
I was talking about the left add and how.
Oh, yeah.
Culturally, people would not use that. It's like
So,
but if it explodes and becomes the next C++ implementation, who knows?
the implementation of the left add function, single line of code, but you end up downloading like 100 lines of code because you're downloading the package JSON and the README and the license and like its GitHub workflow and whatever. So instead of just using add start that's built into the language now, people are still using left add and they're still paying this cost for something that already comes with the language and has for like 5+ years.
I kind of want to go through all of my repositories that I have, like just locally, look through all of my NPM all of my node modules.
You're gonna get into an RC kind of thing, like where you're all of a sudden gonna be building a rabbit
It's
hole.
okay. You can just use ripgrid.
Something crazy I noticed. I'm one of those weirdos who has like my own specific ESLint config published as a package on NPM so that I can use it in lots of different places easily. And if I go and create a new node package, and I just add ESLint and ESLint config Kayla, which is my custom ESLint config, that immediately gets you up to like 20,000 dependencies because TypeScript ESLint is absolutely insane, and they're doing all of this terrible over-modulification of everything. It's really bad. Just because you want code linting, right? Something that should be built in. Something that languages like Cargo and Rust and Go and plenty of others just have as a thing that you already get.
Languages like Cargo feels like a nice thing to say about Rust.
Yeah.
That's the funny thing is Rust I think has the closest thing to NPM as its package manager.
Yeah,
Like when you
Yeah.
go to install like a Rust program or something using Cargo, it is insane how many packages you download.
That's why I said the Go thing, because it's literally like you get your direct ones, and you get indirect, which is usually a very short list in most cases. It seems like it matches the Zig mentality.
Yeah.
As close as I've seen, there's probably a better way, but so far I haven't seen it. But I would say would it change the way that you'd have to do imports and includes? Because like in Go, you're explicit. You say, going from this exact Git repository to this file to do my. It's not like standard .mem. Like you're being very explicit.
So, and the way that Elm does this is like in your dependency manifest, you have to put the full URL. But then when you're in the actual code, like the modules all get to declare their own module name, and then you just use that directly. So
Kind of like an import map. And
you might be using a dependency called like rt feldman /list extra. I forget who actually maintains that. But then when you're like using it in your code, you wouldn't have to say like the actual author's name. You just say like import list.extra, and it can just like define that as its name.
I mean, that's kind of what Zig does already. You define what packages you've got, modules that corresponds to.
But instead of being by a folder based like right now, it's kind of like stud.mem. Like you're in a folder as opposed to like I'm somewhere on the. Because the one thing that about being the explicit URL is that when you say like go mod tidy, it literally grabs everything. Like it knows exactly where to grab it. Like you don't have to try to guess where things are at. Like it's very explicit. So to do that would be a change in the way you do imports, which I don't know if they're would be a problem.
Oh, I was gonna say one of the downsides of using a URL for the package name though is that means if you want to change which version of the package it's using, you either need to come up with another scheme for describing that, or you can't.
Yeah, there's the tag stuff that's in Go, but again, I don't know the Zig answer to that. Like, it'd be interesting though, because I think it's an interesting pathway as well.
Like major versions in the Go modules ecosystem are an absolute nightmare.
Yes.
To the point where like most people just once a package hits V1, that's it for life. If they actually care about making a breaking change, they will make a new package in a new repo. Because it's so much easier than
I've noticed
the way
that.
actually supposed to work.
That's hilarious. Well, and like,
Yeah, I was just going to ask if you have any thoughts about Alan's philosophy on enforcing semantic version by looking at.
Oh, I love that. I love that so much. I think that kind of thing is so cool.
Yeah, because in Zig, you can have a function which takes any type and then use comp type features to determine whether it's the right kind of type you want.
Yeah.
And so it'd be a little bit difficult at the moment to have a sophisticated enough analysis to actually describe what a function signature is because it's so expansive.
That would be cool though.
Yeah.
So,
everyone's like, oh, it's like the mock engine, that's going to need to have like a bunch of dependencies, so it couldn't exist in a world where dependencies can't have dependencies. It's like, well, I'm seeing in my head, you go to the README for that project, they just have like a list of like the dependencies and what version they represent.
Or is there like a deps.zig that's literally like build.zig where you just like, you lay out your stuff and then it becomes, you're basically doing the same thing as Go's like indirect, but you're being more explicit about it.
That's basically what happens right now with the build.zig goes on.
Well, because you're still having to be explicitly downloading your own in your build.zig, right?
Right. Well, the change here would be that you have to copy all of their dependencies into yours.
I feel like the idea of not having
big man for it.
the idea of not having arbitrary code execution feels like so un-Zig though. That's like
That might be a problem.
What's your most important feature? Comp time. What are you taking away? Comp time.
I mean,
So, well, and like maybe having arbitrary code execution at build time is a reasonable thing. The main thing that I'm trying to say there is like saying Zig install something. That should not do anything yet. I should at least have to like go build it so that if I typoed the package, I don't just like immediately get my whole computer ransomware.
So this is where the proxy again. You come back to the fact. I know, like the fact that it's being proxied and it runs in a sandbox. It gets tested before it goes out to like be like. There's value to that, unfortunately. Like it sucks, but there's value.
Yeah.
or who cares if they're running code on my machine when I install it? They're running code on my machine eventually anyway. That's the whole point.
Or that reminds me, Reason ML, it's like this alternative syntax for OCaml, and it's super niche. It has its own package manager though, instead of OPM, it's called ESY. I don't know how they actually pronounce it, because I'm not really that.
It's pronounced easy.
Okay. But like so it will, my understanding at least is that it does let dependencies just run whatever they want, but it does it in like this super sandboxed down way that they put a ton of effort into making work cross-platform. So like on Linux it'll use namespaces or whatever, but then like on macOS has its own different set of primitives that it will also use there.
Yeah,
Yeah, that's
and actually, so one way you could just use Molazo, that's better.
Yeah.
Just sandbox it. You still run into the issue of if you're depending on source code, eventually they're going to be able to run anything on your computer if you're running binary there.
Yeah.
So
Well,
you still need more than just that.
yeah, and like you said, taking away comp time would like really violate the spirit of SIG. Because there are languages like in Elm, the only way to do anything that's side effecting is to have a command type that implements the effect. Or in Haskell, you have IO, and like there are other like fancy functional monadic programming languages that do whatever stuff. But I just think that those programming languages are interesting because they don't even let libraries have arbitrary code execution at runtime, because the only way that they would be able to do that is to expose to you, hey, I'm returning this IO that is going to run something, and you are aware of that because it's in the type system.
So there was actually a cool idea behind monads and monoids in the category of uniform.
Yeah, monads are cool. Monads are cool as shit.
Burritos. They're actually burritos.
They're actually burritos.
So what?
It's a terrible name, but like they're actually super cool, very practical.
I just can't bring myself to write any of like Haskell. Forget about it.
That blog post about how monads are actually burritos is famous, right? If I'm not tripping. What? There's a. Maybe I.
What's not famous? I didn't hear you.
Monads are burritos?
Yeah, there's a blog post about how monads are actually burritos. I was under the impression that it was famous.
Okay, you gotta post it on Discord.
Yeah.
I haven't heard about it.
Could just be the
But I kind of want to know why.
As just a bit of history, Go didn't have a thing for over a decade. Like any kind of vendor.
They're a great case for my point I was making.
No,
Like,
I-
SIG is doing just fine without package management
But-
as is. Like, look at Tiger Beetle. They're doing such cool stuff,
Yeah.
and like, they don't care that SIG doesn't have a package manager yet.
The only thing that I will say about that, because I agree, like it's kind of fine. You just vendored everything. You just kind of handled it. The problem was when everyone made their own different version. There's competing factors, and then the Go just said, "No, we're going to do one," and it bifurcated the community. And it was almost a Python 2 to 3 thing. And if it wasn't a big, like Zig isn't as big, so there's a concern if you don't agree to something earlier, you could do the Python 2 to 3 thing, which is
Yeah, it should maybe be a pre 1.0 thing still, but like
Yeah.
it's also not something that we need to run towards as fast as possible. I guess is my point.
I would also venture to guess that if Go was not owned by a mega corporation,
and it could
had
force it.
so many resources to put into getting developers behind this programming language, that not having a package manager would have hurt them
I agree.
really bad.
I had a really great time. I loved everyone's talks, but I have to end it.
Yeah.
It's great to be with you guys.
Cool.
See ya.
All right.
Cool.
Well, it has been great, guys.